All right. Good morning, Calc 1, right? Okay, for all you people, Dankeschön. Okay. All right. All right. Finding rates of change in biology experiment. In a metabolic experiment, the mass M of glucose decreases according to the function. So it's decreasing, right? Say yes.
Yes.
Okay, so it's decreasing, so it means that it should be doing what? Going down. Yeah, basically, right? So what do we know if it's going down? What about my slope? Yeah, it's not yarrow. What is that yarrow actually doing? It's what?
Negative.
Negative. Thank you. That's what we're looking for here. Okay? So when we're actually talking about these things, if you understand the problem, you could actually think of it conceptually. Because if you get some weird number, you're like, oh, okay, it's a positive. That doesn't seem like it's right. So I need you guys actually thinking about what it's saying. Yes, it is a word problem. Yes, you have to read those words. All right. Where M is measured in grams and T is in hours, okay, find the reaction rate of M prime of T, okay, at T equals 1. So that means that T is going to be my time in which I want to find the rate there. So let's go through, and if I were to do my derivative, okay, I would do the derivative. So it would be my M, actually it's a limit, right? So the limit as approaches 1, right? So it's going to be 4.5 minus 0.03 t squared minus, that's going to be 4.5 0.03. If my t is 1, right? My t is 1, because on the second part I plug in 1, so it's just going to be 1 times that, right? All over x minus 1, right? Or t minus 1, sorry, thank you.
Wait, why are you putting it over?
Okay, so this is a slope formula, so it's f of c minus f of x over, no wait, backwards.
F of x minus f of c.
Yeah, sorry. So it's f of x minus f of c over x minus c. So it's a slope formula. All it is a slope formula. Okay, so this is going to be y1 minus y2 over x1 minus x2. Slope formula. We just have a x value to go with the y value. F of x is going to be the y value. C value is also the x for a different point, where f of c is plugging in that x value to get the y value there. That's all it is, slope formulas. Huh?
Are you plugging in the c and not the x?
Okay, my c right here is going to be 1. And that's where I got that. Okay. I want you over here. Because I'm right-handed, so I keep like having my back to you. I want to make sure that you...
Just right over.
Huh? Oh, you know what? I'm ambidextrous, but then I'm going to be blocking everyone else.
No.
Huh? So yeah, see, I'm like blocking other people. Anyway, but still. All right, so now we're going to start doing some math here, right? We're going to do some math. So now, as I do this, do you guys have your calculator out right now? Okay, please do that.
It's going minus 0.03.
Okay, so you actually have this. So as you plug this in, you subtract it, because don't forget, you also have to distribute the negative here, right? You have to distribute this negative. So it should be, okay, so tell me what it should be. Minus
0.0 t squared.
0.03
t squared
t squared plus
0.03. I don't know what to say.
all over
T minus 1.
t minus 1 right there, right?
Yes.
You
1.
said 0.103?
Hmm?
You said 0.103?
No, 0.03.
Yeah.
Oh my
Okay, hey, this is right, isn't it? Yes. What can I factor out?
You can factor out minus 0.03 and then
Yes, I'm going to factor that out. I'm going to factor out the negative, so it's going to change it.
0.03.
So it's going to be a negative 0.03, and I'm going to be left with,
T squared minus 1.
this is going to be t squared over
T minus
t minus 1, right?
1.
And since I was able to pull out all that decimal, that nastiness, okay, and so I cleaned it up a little bit. Now, can I factor that t squared minus 1?
Yes.
So when I factor that, that's going to be difference of squares again. So I'm going to have negative 0.03 times t plus 1, t minus 1 over t minus 1, right?
Yep.
And so t minus 1s will cancel. And now can I take the limit as x approaches 1? Yes? Okay. So now as I do that, so as x approaches 1, this gives me what?
Minus 0.
This is 2, right?
Negative 0.
This is 2 in here. 2 times this. So it's going to be negative 0.06. That is going to be my slope when. That's going to be my slope when. Hey, if you got questions, please ask. So,
That's what
no, ask.
I'm just kidding.
Speak up. Seriously, if you have questions, you need to ask these. That's why I'm here. You know, you can't ask the YouTube video.
How do you put it?
How did I get what?
Negative
No, she actually can.
This one right here?
From the last
And
step.
you can use
From
one.
the last step? Yeah.
This?
He just plugged in one.
Oh yeah, you're just plugging in 1. Taking the limit as x, or I'm sorry, t.
Like it's
I always do this, because especially when I change and I'm like, t's. Okay, so this says that I'm plugging in 1 for my t.
Oh, okay, no, I got it.
Okay, so now 1 plus 1 is 2 times
Right,
that.
okay, yeah, sorry,
Alright, so it asked for the slope. Find the reaction rate. So now, in this case, since this is a biological thing, that means that at 2 hours, it is going down at a rate of negative 0.06. And what are my rates? What is the rate? What is the rate of change? Okay, now, what are my units of change? That's better to say. No. Okay. So when you're driving through that, elementary school zone on your way to school this morning,
Like miles or
it's what?
miles per hour.
Okay, that would be miles per hour because you're probably doing like 80 miles per hour. So that is a rate of change. And this rate of change is going to have a units of grams per hours, right? So that's grams over hours.
Wait, you said 2 hours? So you said,
Okay, so see this right here? When this is 1, plug in 1 for the t,
yeah.
right here. So 1 plus 1 is? That's 2, right?
Yeah.
I get 2, and 2 times that gives me this. Better? Alright, hey, you know what, seriously, are we okay now?
Yeah.
Okay. Which one are you looking for? Are you looking for this?
Is this the one we got the other day?
Yeah, this is
Oh, okay,
Tuesdays.
so we didn't get a new one?
No.
Alright, cool.
Okay. Alright, so, now this one right here, finding average velocity. Now this one, Mike O'Callaghan, Pat Tillman Memorial Bridge spanning Colorado River, is started then, having a span of there. Longest arch bridge west of Hemisphere, and his roadway is 890 feet above the Colorado River. If a rock falls a runway from the roadway, the function is this. Okay? Gives the distance s. So my distance in feet that the rock falls after t seconds. So it's the distance from the bridge. That's what it's actually calculating. So, and it says rock falls after t seconds from 0 to 7.458. What do you think that's 7.458? Why is that in my domain?
Because it's the limit of time that it
2 seconds.
Say it. You're right. Say it with confidence.
takes. Because it's the time in which the rock falls.
Yeah, the time in which the rock actually falls to hit the ground at 890 feet. Okay, that's how long it's going to take for it actually to meet that. So that is the domain of this. So it can't fall forever. It's got to fall, for a certain time period. Okay, here, this is the approximate time it takes for the rock to fall that 890 feet to the river. Average velocity of the rock during its fall is, so we're going to find the average velocity. So if I'm doing an average, what would that do?
Get all the different numbers and divide that out.
Okay, so I'm just basically asking for a secant line. So from the start to the end, right? Say yes.
Yes.
Yeah, so I'm going to find the secant line from start to the end. So I know, I think this one has, wait, no, I wasn't supposed to do that. So I'm doing the secant line, so it's going to be my, it's an S of t equals 16t squared, right? And it's going to be between 0 and
7.458.
458?
Yeah.
Okay, there we go. So, now I have 2 points here, right? I have my starting point. What is the x value of my starting point? Or, better, what's my t value of my starting point?
0.
0. What is my t value at my ending point?
7.
Very good. So, let's do the slope formula for this. Okay? So, it's basically finding the slope in between those two endpoints, right? So, this is a secant line here. So, for this, it's going to be, here, I'll write out the function first. 7.458 minus f of 0 over 7.458 minus 0. Because I have 2 points, right? So if I want to just do an ordered pair, 0, comma, okay, if I plug in this to get the y value, what would that be? Or plug in 0 for this. 0. So the distance it's traveled is 0 at t seconds of 0, right? Okay. So now at 7.458, comma, it should be at 890. Right?
Yeah.
Because that's when it's supposed to hit the water. Or hit whatever smashing it at the bottom, right? Jagged rocks. Okay. Anyway, so that's what I should have there. That should be my distance there. So now I have 2 points, right? So I'm finding the slope in between those 2 points. So let's go ahead and do this. So I know this is 890 minus 0 over 7.458 minus 0, right? So it's 890 over 7.458, and that's going to give me approximately
119.3.
point what? Okay, so now, is this a rate of change? Yes, it is a rate of change, right?
Yes.
It is a rate of change. So what are my units on my rate of change?
Miles per second.
It's what?
Like, no, not miles.
What were my units?
Miles per.
Feet.
Not miles.
Feet.
What is
Feet.
Feet.
It's feet. Okay, so feet per second. So whenever I'm talking about a rate of change, you have to identify what it is we're talking about. Feet per second, miles per hour, those things. Or if someone is driving through that school zone, it's how many children they hit per minute, right? So,
7.
How do you know?
okay. Does it make sense?
Yes.
So just practicing with this is going to help you out a lot.
I think it's just remembering, like.
Everything's slow.
Yeah, that's what I was saying.
Everything is slow formula. Okay, so now for this one right here, if S equals f of t, function given the distance that S travels an object at time, instantaneous velocity, v of the object at t sub naught is defined as the limit of the average velocity of my distance over time. The change in distance over the change in time. And it's only if the limit exists. So that's the exact same thing that we just did. So, previous example. Okay, we did the previous example, right? So if I had S of t is 16t squared, so S prime, okay, I can go through and actually find this out. So it would be at 1 second. Okay, so it's going to be S prime of, that's an S, I even said S. So S prime of 1. So let's go over here. So it's going to be, let's see, that would be 16t squared minus 16, right? Because we're finding it at 1, right? We're finding it at 1 over t minus 1, right? Can I factor anything out of the top?
16.
Take out a 16. 16, I'm left with t squared minus 1 over t minus 1. Difference of squares again, right? So it's going to be 16 quantity t plus 1, t minus 1, t minus 1, right? So I could cancel out that t minus 1. And I'm going to have 16 times t plus 1. So I'm trying to find it at when? 1. So at 1, so I plug that in. So when t is equal to 1, so the limit as t goes to 1, so that's going to be 2 times 16 is 32. So that is saying that it is going to be what? 32.
Feet per second.
There we go. 32 feet per second.
Wait, never mind.
Do you still have to put per second?
Okay, so when we did this right here, okay, we're doing a rate of change. Remember, it's a slope is always going to be a rate of change. So we have right here. This is a position function. This would, if I plug in a number here, that's going to tell me the distance it has traveled. But it's not distance over time. It's just the straight distance. Okay? So this is at this current moment, it's traveling at 32 feet per second. Okay? That's the rate that it's going at, like your miles per hour. Okay? So now at the next one, so just before it hits the river, so you guys are going to need calculators to do the happy math on this one. Alright, so it's the same thing. So t sub naught, so it's going to be 16t squared minus 16 times 7.4 squared over t minus 7.4. Right?
16 t squared minus 876.16.
Okay, so now I'm gonna do some weird math on this, because I don't like that, and I'm just gonna like factor. Okay, I don't want to square all that. I don't want to actually deal with decimals. So I can factor out a 16 already, right? So I'm gonna end up with a 16 quantity t squared minus 7.4 squared, right? Yes? Is this a difference of two squares? It is still a difference of two squares, even though it's ugly, but that square right there is telling me it's a square, right? So even though it's not like a perfect square number, it's still difference of two squares. So I can still write that as 16 parentheses t plus 7.4 and t minus 7.4 all over t minus 7.4, right? So the math looks funny, but guess what? It works out. Okay, that's what those squares help me out with. Cancel that, cancel that. So now I have this. Now can I take the limit as t approaches 7.4? 7.4 plus 7.4 is 14.8 times 16.
236.
What is it?
236.8.
So it's going to be s prime of 7.4 is going to be 2 what?
236.8. What?
Is it only 0.8?
Yeah,
Don't forget, you need 3 decimals.
Just 0.8.
Okay,
Nothing.
0.8. Now, units again. There we go. So, it is traveling at, right before it hits the water, it's traveling at 236.8 feet per second. That is a lot of feet per second. That's going really fast. That's why jumping off high bridges, when you hit the water, it hurts. It's painful. Okay? So yes, you get a quick enema.
You really hella complicated that because you literally could have just taken the 32 feet that we got times 7.4.
Will it always be linear?
Yeah,
So,
because I said something.
And,
But
Because we're using small numbers on this one. So when we have higher order polynomials, it doesn't work. Okay. Same thing here. Okay. Now, for this one right here, find the derivative of a function at a number. Now, this one is not so pretty because it is a higher number polynomial, right? So, that means a whole lot of factoring comes into play here. Now, I'm going to save you guys a little bit of bacon on this. I'm going to teach you guys the power rule, and we're supposed to learn the power rule next lesson.
Is it gonna be 5?
Huh?
Is the answer gonna be 5?
I don't know, maybe.
Yeah.
So, the power rule,
Michael taught this.
you take your exponent and you times it by the number in front. So, f prime of x, the power rule, take this number, multiply by the front, that's going to give you what? 4, and then you subtract 1 from your exponent. To the 1, right? Okay. Same thing goes here. So what is this going to give me? Minus 3. Now, if I take 1 away from my exponent, that's just going to become 0. So that's going to, so it's going to be 1. X to the 0 is 1, right? And so since this has no exponent right here, or no variable, that drops off.
What the crap? That's not allowed.
It drops off because it actually, as we go down in degrees, if it is a constant like this, it goes away.
Wait, why did you get rid of the X on 3?
Okay, so now, subtract 1 from this. Did you
Yeah,
understand that?
Yeah, I get that, but like you would just get
Okay.
rid of the variable?
Now, watch this. What's x to the first minus 1? So that's x to the 0, right?
Yeah.
Okay,
So it's 1. Oh, so it's just 3 times 1.
yep. So, does that make sense?
Yeah, so you're doing it on the variable, not the number.
Yeah, the variable. It always goes with the variable. And since this has no variable,
You just don't.
that goes away.
So your answer,
the fuck, bro?
You know I'm recording this, right?
that was
The
Edith.
beat, bro.
That was Edith Aaron Terrell.
Yes.
Yeah.
All right, so now listen, you guys are gonna love this way,
No.
because all the thing that we've been doing with factoring and all that, you're never gonna do it again.
Why were we not taught this before?
You need the limit process. All right, so now this is saying f prime of 2. Watch this. F prime of 2 is going to give me 8 minus 3 is.
Oh my god.
Bro, I hate you.
There's my voodoo way.
Wait, so for the first one, you
Wait,
multiplied by the exponent, right? And then dropped 1 power, right?
Yep.
Okay, just making sure.
Wait, no,
So
that's mine.
I can actually go back and do. Watch this.
No.
If I did this one also, f prime of t is going to be, if I do the same thing here, watch, 32t, right?
Bruh.
Okay, so now, so f prime of 1 was 32. F prime of 7.4,
Ew.
that's why I said it only works on that one.
Why?
She was saying that all you do is just plug it in and multiply it, but it only works when it's comes out like this. So, you like my voodoo math?
I hate you.
Okay, you can hate me all you want. All right, here's some more stuff. All right. Okay, so all that is under the radical. Watch this.
No.
You guys are going to get mad at me for this. So f of x is going to be radical 2 times x. Now, can I write that as a power?
Yes.
I could 1/2,
That's what
right? Because I'm separating these right here. I'm separating those. Because I want the exponent. I really do. So if I do what I just said, right? So multiply this times the front.
So half times 2. So
Half times this, so it's going to be radical 2 over 2, right? Okay, and it's going to be times. So now, what did I do?
Negative 1 over
Yeah.
X to the,
negative 1 over
Or,
right? You take away 1, you get that. So now, what would I do with my exponent if it's negative? Move it to the bottom, right?
so x over 2. X over negative 2.
That's it.
That's it?
That's your.
All right, so
That seems
this is the correct answer right here also. All I did is I put this, it's a negative exponent, I made it positive in the denominator.
that seems so
It's my voodoo. Listen, we could do the whole math on this to show you that it works.
no.
It works every time.
That's
Okay? So, find the derivative right here. Use the derivative. Okay, now let's find it at 8. So, f
the exponent
prime of 8 is going to give me what? Plug in 8 here. Radical 2 over 2 times square root of 8. You know, I'm just going to go straight to rationalize. I'm not going to factor it. Square root of 16 over 16. What is square root of 16?
4.
Which reduces to?
4.
It's that good voodoo.
Wait, you made the jump. What happened? I know you skipped it.
I did skip a step.
Yeah, you didn't rationalize, right?
No, yeah. Okay, because right here, 8's not a perfect square, right?
Yeah.
So I rationalize here. And when I rationalize, it's rad 2 times rad 8 gave me rad 16, right?
Yeah, and then 4
this right here. Square root of 8 times square root of 8, square root of 64.
Oh, yeah.
Square root of 64 just gives me 8, right? This is going to give me 8 times 2 was that 16. Voodoo. Alright, so. Okay, I guess we're running out of time on this. I guess I'm going to finish up these notes tomorrow. We only have one more example to finish. So, don't forget, like and subscribe. We have to finish this one.
Good.
Remind me tomorrow, finish this one.